I'm going to discuss is vector. First of all, why we need vector and what is its importance, right? What's importance? What is it? What its importance as well, right? Its importance. So why vector? For example, if you'll ask any boy to move 5 meter, but still he's not aware of the direction if we are to move, and then you indicate that 5 meter in east, 5 kilometer in east. So now it's pretty obvious that we know about this direction, which is in north, south, west and east. Now he's pretty obvious that he has to move in the east 5 kilometer, right? So vectors quite important to indicate the direction. Now what's the proper definition of vector? Vector has unit, magnitude, direction, and yes, follow vector law of addition. This point is very it's a key point that it follows vector law of addition. Without it, it's a tensor quantity, which means that it has unit, magnitude and direction. It still not follow the law of factor addition, which means a tensor quantity. So for being a vector quantity, it's needed that it should follow the law of vector additions. Now we can discuss what are laws of vector addition. For example, parallelogram law, triangle law, polygon law, and there are a lot of law that we'll be discussing later on, right? So it should follow, for example, for vector, what's needed? Magnitude, direction, and yes, vector law of addition, right? So this is the thing, this is important thing, right? Vector, we know that vector quantities have direction, but remember that all the directional quantities are not vector. All directional quantities and vector until they follow vector law of addition. For example, current, we know that it's a three-dimensional spaces. I'm sorry. This is x-axis, y-axis and z-axis. For example, I could say that there are three-dimensional spaces here. For example, this is 3 ampere, oh my god, 3 ampere, 4 ampere, and 3 plus 4, 7 ampere, 5, 3 plus 4, 5, 6, 7, 7 ampere. So it's a simple addition law that we are applying here, not a vector law of addition, which is quite different from this. So it's a tensor quantity, right, which has magnitude, direction, unit, but still not follow the vector laws of addition. That is, it's a tensor quantity. So this is a basic introduction that we have about vector. Now later on I'll be discussing about the representation of vector in the next video.